Affinity propagation clustering. Algorithm affinity propagation clustering. Pseudocode steps. 1. Data preprocessing. Description: prepare the data for clustering by handling missing values, encoding categorical variables, and scaling numerical features. Steps. Handle missing values imputation. Details: replace missing values using mean, median, or interpolation methods. Encode categorical variables if necessary. One-hot encoding. Label encoding. Details: convert categorical variables into numerical format suitable for clustering algorithms. Scale numerical features: standardization or normalization. Details: standardize features to have zero mean and unit variance or normalize them to a fixed range. 2. Model training and clustering. Description: train the affinity propagation model using the preprocessed data. Steps. Compute similarity matrix based on input data. Details: calculate pairwise similarity or dissimilarity between data points using a chosen metric, e.g., Euclidean distance. Cosine similarity. Initialize availability and responsibility matrices. Details: set initial values for matrices tracking the responsibility of each point for other points, and the availability of each point to become an exemplar. Update availability and responsibility matrices iteratively until convergence. Details. For each iteration, update the responsibility and availability matrices. Update responsibility matrix RE, JD, J, max I. C. Update availability matrix AI, J minsum R, J, RE, J. 0. Check for convergence criteria, e.g., change in matrix values tolerance. Determine cluster centroids based on matrix results. Details: identify cluster centroids by selecting data points with the highest responsibility values. 3. Evaluation and validation. Description: evaluate the clustering results using various metrics and techniques. Steps. Evaluate clustering quality using metrics like silhouette score, adjusted rand index, or Davies-Bouldin index. Details. Silhouette score measures how similar a point is to its own cluster compared to other clusters. Higher values indicate well-defined clusters. Adjusted rand index measures the similarity between two clusterings, correcting for chance. Davies-Bouldin index measures the average similarity between clusters, with lower values indicating better clustering. Handle noise and outlier detection through cluster analysis or outlier detection methods. Details: identify and manage noise and outliers using techniques like DBSCAN or robust clustering. Methods. Assess cluster stability and robustness. Details: monitor how clusters change over time and evaluate results across different datasets to ensure consistency. 4. Handling categorical variables. Description: process categorical variables appropriately for clustering. Steps. Encode categorical variables using suitable techniques. One-hot encoding. Label encoding. Details. One-hot encoding convert categorical variables to binary vectors. Label encoding assign a unique integer to each category. 5. Fine-tuning and optimization. Description: optimize model parameters and settings for better performance. Steps. Fine-tune parameters such as preference and damping factor based on evaluation metrics and domain knowledge. Details. Preference controls the number of clusters set based on the dataset's characteristics. Damping factor helps in stabilizing the iterative process, typically set between 0.5 and 0.9. Adjust similarity measure or clustering criteria to optimize performance. Details: experiment with different similarity measures, e.g., Euclidean, cosine, and adjust clustering criteria. 6. Handling uncertainty and drifts. Description: manage uncertainty and detect concept drift in the clustering process. Steps: monitor cluster stability over time to detect concept drift. Details: use statistical tests or monitoring systems to detect changes in data distribution. Implement 3 clustering strategies or update clustering parameters based on drift detection. Details: adapt clustering parameters or retrain the model when significant concept drift is detected. 7. Test case criteria. Description: define test cases to validate and assess clustering results. Steps: define test cases to validate clustering results against known ground truth or domain knowledge. Details: select datasets with known cluster structures and validate the clustering results. Evaluate clustering robustness across different datasets or subsets. Details: test the algorithm's performance on diverse datasets to ensure its generalizability and robustness. Evaluation metric. Description: metrics to evaluate the quality and performance of clustering. Metrics: silhouette score. Details: measures how similar a point is to its own cluster compared to other clusters. Higher values indicate better defined clusters. Adjusted RAND index. Details: measures similarity between two clusterings. Correcting for chance. Values range from -1 to 1, with 1 indicating perfect agreement. Davies-Bouldin index. Details: evaluates the average similarity between clusters. Lower values indicate better clustering quality. Visualization methods. Description: techniques to visualize and interpret clustering results. Methods: visualize clusters using scatter plots with cluster centroids or representative points. Details: use plots to show data points and their assigned clusters. Plot cluster assignments and visualize the clustering structure using dendrograms or heat maps. Details: dendrograms can illustrate the hierarchy of clusters, while heat maps can show similarity matrices.